Tungsten West was founded in 2019 with the sole purpose of buying the Hemerdon tungsten tin deposit out of receivership. After buying the project out of receivership in 2019, Tungsten West went and did test work on the ore body to understand the metallurgical responsiveness for different techniques to separate the tungsten and the tin out from the gangue minerals. This has all been culminated in a couple of years of work, which has been compiled into a bankable feasibility study. We published our BFS a few months ago. The capex required to restart and rebuild the processing plant is about £35 million, and it'll take us about 12 months until we restart the processing plant. The BFS has a 23-year life of mine associated with it. That makes it the second largest tungsten reserve outside of China. Tungsten is a strategic and very critical mineral, given its applications in the automotive sector, oil and gas, space, aeronautics, and several other applications.
So behind me here we have the Hemerdon deposit. Our calculations put that as the third largest tungsten resource in the world. The Hemerdon deposit is centralised around what we call the Hemerdon granite. This is a body of intrusive rock. It was molten and pushed up into the Earth's crust about 292 million years ago. So this is actually one of the oldest granites in southwest England, if not the oldest, and we believe that's a key reason why there is so much tungsten here. At the end of last year and the start of this year, we had a fairly comprehensive drilling campaign. The drilling we did was to test the continuation of these high-grade zones, particularly down plunge, and two of the holes we drilled, particularly in the northern part of the deposit, I believe were the highest grade intersections ever drilled to date at site. So it's been an extremely rewarding exercise and had a very positive impact on the economics of the project. So we're standing on fresh rock in the base of the Hemerdon open pit, and behind me you can see some of the mineralisation exposed in these rocks that shows the sheeted vein nature of the system, and within it the quartz veins that contain ferberite, which is our ore of tungsten, and cassiterite, our ore of tin. One of the crucial difficulties faced by the previous operation was the upper portion of this deposit, i.e. the material that's been removed above us, was heavily kaolinised, i.e. the granite had been altered into a china clay, as is mined in other areas of southwest England. Fortunately for Tungsten West, that material has been mined out, and we're now sitting on the fresh rock, as you can see, that is much more metallurgically amenable to the processes we have and the processes we'll install, and ultimately should lead to much higher recoveries for the future operation.
One of the big focuses of Tungsten West now and Aggregates West is the utilisation of all the waste streams that come out from a metalliferous mining operation. Under the previous Wolf operation, this was never explored in any great detail, but under our new operation, under Tungsten West, we're now looking to capitalise and utilise every single product, every single waste stream that comes out of the minerals processing facility.
The whole concept of what we're trying to achieve here is to provide sustainable aggregates to support Britain's built environment. We are displacing material from the pit to the mine waste facility as a metalliferous mining operation, and we want to make best use of those byproducts, those secondary aggregates, and introduce those to the UK market.
This releases some immediate cash flow for Aggregates West as a business and supports obviously the Tungsten West restart operation. Part of that process has been not just exploring the geochemistry and the geology of the rock type and exploring what production process we need to get it to that end user specification. This has also been looking at our regulatory processes in terms of environmental permitting and planning decisions. As part of this process, we've explored all of the infrastructure across the southwest region, and this goes from the road networks, this goes into the shipping networks and the shipping port facilities. We look at the rail networks and all of the requirements that come with that. Part of this process over the next 12 months is bringing together some of those top mines from around the UK and exploring all of the options that we have available, from processing, geology, production and route to market. Our big driver within this project is sustainability. Everything we do has to have sustainability at the forefront of our agenda. We are a green company. Our aspiration is to follow in the footsteps of obviously the UK and drive forward all green agendas. We are looking at how we can utilise obviously the existing infrastructure and look at how we can drive the energy requirements and demand of that infrastructure down to impact less of a carbon footprint.
Tungsten West Limited was founded on environmental social governance principles. Our first aim was to go out and achieve ISO 14001 environmental management, 9001 which is quality management, and 45001 which is health and safety. Basing the business on those principles, we are able to meet all regulatory requirements for all of our regulatory stakeholders, including the Devon County Council and Environment Agency. So this is our main environmental discharge point currently. This is where we discharge trade effluent to the environment. We control the quality of the water here by monitoring the suspended solids, dissolved copper, aluminium and pH.
As a company, we have a strategy of being carbon neutral by 2027. We're looking to replace our trucks, our shovels, our excavators with hydrogen-powered vehicles, and it's something that we're working with Plymouth City Council and the Royal Navy, who both have a policy of replacing the bus fleet and the vehicles at the local port with hydrogen-powered vehicles when that is technically feasible to do so.
The project was run by Wolf Minerals for 3 years. They spent £200 million on the project, however went into receivership in 2018. The project went into receivership predominantly due to key problem areas associated with the processing plant. The two areas of main concern were plant availability, the fact that the processing plant wasn't on that much of the time, and low recoveries, the fact that they weren't able to recover as much of the tungsten and the tin as they were forecasting. Those two issues coupled together meant that they were getting very poor payability on the tungsten and the tin concentrates they were selling. After making several improvements to the processing plant, a lot of good work was done in the 1980s in terms of understanding the variability of the ore body, and a process plant design was formulated thereafter. That information and design was then taken under Wolf Minerals, and that's where you see the processing plant being built today. Now that the processing plant is turned off, it's far easier to implement the changes required to bring it up to where it should be. With regards to the plant availability, we're changing out the entire front end of the processing plant. So this is the processing plant. The aim of the game here is to concentrate the material that is fed into the front end of the processing plant and concentrate it from 0.2% tungsten up to roughly 55 to 65% tungsten. The processing plant's broken down into 3 key areas. The first area is the front end of the processing plant, where you do the comminution and classification, i.e. you crush the material down to size and then you screen it out so it enters the concentrator circuit. Concentrator circuit is the second area of the processing plant, where you are concentrating the tungsten and the tin minerals, separating them from gangue minerals to produce a pre-concentrate. Thereafter, the material is sent to the refinery, where it's upgraded for final concentrate. Once the tungsten tin minerals have been liberated, the fines reports into the fine gravity circuit here, where you take advantage of the specific gravity of the tungsten tin minerals against the gangue minerals. This is the coarse concentrator circuit. We're using dense media separation. As you can see, there are 2 dense media separators here. One of them has been upgraded to 4 cyclones. One of them is still awaiting upgrade. When we restart the processing plant, we will upgrade this second dense media separator circuit to replicate exactly what's happened to the right. Once the tungsten and the tin have been upgraded via gravity separation, they're then separated out via magnetic separation. So we produce 2 concentrates, tungsten concentrate, and here we have tin concentrate. Towards the end of operations here in 2018, with purely 1 concentrator circuit being upgraded, the recoveries improved significantly. Now that we're going in and upgrading the second circuit, one expects further recoveries to improve. We've taken all that information from the 1980s and turned it into a 21st century processing plant. That's exactly what we're doing with the introduction of X-ray transmission ore sorting, a technology that's only really come to prominence in the last 10 years in the mining industry.
I'm here really to support this project, this very important strategic project to develop the tungsten mine just outside of the village of Hemerdon in my constituency. It's going to create many well-paid jobs. It's hugely important to this region to get this strategic mineral out of the ground and exported all over the world. It's going to be a massive economic boost to our region, and it's going to be done in a way that's sensitive to the environment. So I'm hugely behind this project. The local community is behind this project, and we desperately want it to succeed.
Restarting Hemerdon tungsten tin deposit is absolutely critical for the UK. Not only does it prove to the world that we can actually successfully mine here, but also we're producing two very strategic minerals in terms of tungsten and tin.
Critical minerals are obviously getting a huge amount of press at the moment, given the very large price rises that we're seeing across a number of commodities right now. China has a dominant position in many critical minerals, including tungsten. China mines 80% of the world's tungsten. So to have a very, very large resource, multi-decade resource of tungsten here in the UK is of massive strategic importance.
The other added benefits for the Southwest is clearly the creation of 300 direct jobs. This was a massive job creator under Wolf Minerals. Those jobs are now gone, and we're aiming to restart those jobs within 12 months. Given the size of the ore body, we're going to be here for a while. We've got a 23-year life of mine, so we're not going to be going anywhere anytime soon.
This is a massive deposit of tungsten and tin. It is a world-class deposit. It's going to be a world-class mine, and we are doing all the right things to fix it and to turn it into something that the UK can be properly proud of.